Hey guys, welcome back to the channel. Today we'll be solving LeetCode 11, container with most water. So we're given an integer array called height and a length n, and there's n vertical lines, and we have to find two lines such that they can hold the most volume of water. So in this case, the second line is of length 8, and the last line is of length 7, and it can hold the most water, which is 49. So this can be solved efficiently using a two-pointer technique with linear time complexity and constant extra space. To solve this, we're going to use a two-pointer technique where the left pointer is going to start at the beginning of the array and the right pointer is going to start at the end of the array. And we're going to calculate our current area at every iteration. And to do that, we're going to get the minimum height of the two pointers. So our first pointer starts at a height of 1 and the second pointer starts at a height of 9, and the minimum of that is going to be 1. And then we're going to take that and multiply it by the current amount of water we have, which is going to be the right pointer minus the left pointer, which is going to be 8. So let's go through this example. So we're going to see which one's smaller. So 1 is smaller, so it'll determine the height, and 9 minus 1 is our width, so that's going to be 8, and we're going to multiply that by the minimum height of the two, which is 1, and we're going to get 8, which is smaller than or greater than 0, so we're going to replace the result with 8, and then we're going to shrink the side with the smaller height. So the left pointer has a smaller height, so we're going to shrink that, and then now the minimum is going to be 7, so we're gonna do 9 minus 2, which is equal to 7, and then we're gonna multiply that by 7, which is going to be 49, which is definitely larger than 8. Then we're gonna see which one's smaller. This side's smaller, so we're gonna shrink it from the right this time, and then we're gonna check. It's gonna be 8 minus 2, which is going to be 6. And I forgot to move this up. So currently we were up here, and now we're gonna be here, and we're gonna check the minimum of the two, and that's going to be a height of 3. So we're gonna multiply this by 3, which is 18, which is not bigger than 49. Then we're gonna shrink towards the left from the right because it's the smaller one, and then this is actually gonna go up here, and we're going to do 7 minus 2, which is going to be 5, and we're going to do 5 times 8 because the minimum of both of them is the same, so it's going to be 8, which is going to be 40, which is still not larger than 49. And we're going to keep iterating until these cross or meet each other. Then it doesn't matter what side we shrink this time, so we'll just shrink this one, and then we're going to be down here, and it's going to be 6 minus 2, which is 4, and we're going to multiply this by the minimum of the two heights, which is going to be 4, which is 36, and it's still not larger than 49. So we actually found our result very early on because nothing is going to be larger than this. And then we're going to calculate this, which is going to be 5 minus 2, which is 3, times a height of 5, which is 15, and that's still not larger. Then we're going to move this down here, and we're going to do 4 minus 2, which is 2, multiplied by 2, which is 4, which is still not larger. And then we're going to move this to our final iteration, which is going to be up here. And That's just gonna be 6, yep, 6 times 1, and that's just 6, and that's not larger, and we're done. We found our result, which is 49, so we can just return that. We're going to initialize our result to 0, and then we're going to initialize our left and right pointer. So left is going to be at the beginning of the array, and right is going to be at the end of the array, which is going to be the length of height minus 1. And we're going to keep iterating as long as these pointers don't cross each other, and we can do that like this. Then we're going to calculate our area like this. So we're going to take the right minus the left, and we're going to multiply it. So this is going to be our width, and we're going to multiply it by our height, which is going to be the minimum of the 2 pointers. So the height at left and height at right. So the minimum is going to be the height. And then we're going to see, is this area larger than what's already in our result? If it is, we're going to set it to our result. And then our condition was, if the height, we're going to shift whichever has the smaller height. So if the height at left is smaller than the height at right, we're going to shift the left pointer towards the right. Otherwise, we will be shifting the right pointer towards the left. And after all of this, we can just return the result. Looks like it worked, and it's very efficient. This will run in linear time with constant extra space. Thanks for watching.